Excuse me. Damn. Okay. We are back. Oops. Oh yeah. Take. Okay. Can't remember where we left off yesterday. Yeah, I guess. Yeah. That I was failing, if I remember correctly. Oh, I'm a bit sleepy today. I don't know if it's just me, but I feel like... No, it's not. I thought in my monitor it sounds like I'm talking in slow motion. But I think it's not true. It's fine. It is fine. Right. I think I would double check that. Yeah. At least now I know where stuff is in the data sheet. So control and then the command. A8. First one doesn't look correct. Oh no, it is. Hang on. The display's turned on here. What's this for? Let me just get rid of this. See what happens. Save build. I think it's the whole copying the UF2 file over this. Okay. Yeah. This. Clear. What am I doing? Right. DNS. Firmware UF2. No, there's still an error. You can see the chat on the screen. Looks quite funny. Right, okay. Never mind. Just leave this open. Now, okay, what are the errors? So hang on, go back. Leave that in. What is AE? What does it do? Oh, it's a reset. And let me check this one. So C0 is 0, command yes, so 0, and the rest are all zeros. Why was that 0 again? The C0 bit is 0. Transmission of the following information will contain data bytes only. Make it 1. Binary to hex. 1, 3, 4, 5, 6, 7. 6, 7. 80. Let's try 80. Okay. Connect. Reconnect. Alright. Gotta get that Pico tool. No, still another. Chat is sinking. Quite annoying when that happens. It happens all the time. Okay, that wasn't it. Control byte, data byte, control byte, data byte. Control data, control data. It does look a bit wrong. Control command. Some instances there's 2 bytes. To be fair, he did manage to turn it on. Let's have a look here. Right. It is necessary to do the startup sequence to initialize the display. Yeah. What is it? Yeah, right here. There's two commands there. Eight comma. The fuck is $3 at? In particular, to make sure the charge pump config is set correctly or the display will not be powered. The charge pump. Where is the charge pump? Something I just realized. After you write, you need to like is the address correct? PC. Yeah, it is. Right here. Oh, Also, wondering, do I not need to specify which pin? Yeah, like, so here, specify GPIO 25. But here, yeah, I haven't specified which pin. Wonder, well, I would assume you need to Pico. So yeah, GPIO 0 and 1. Instance. How does Andrew do it? Yeah, it does the same. I square C 0. No, I'm not sure. It's an unsigned 1 bit. That can't be correct. Right? Let's just try putting this to, let's say, we'll use 2. 2. That should be wrong. So type still match. Yeah. So something's wrong. I don't think this is correct. Square C 0 is hang on. Go to microsig source examples. Damn, I think that might be the problem. Yep, Raspberry Pi source I square. I think this one. GPIO. Don't know what this is. Dot instance dot num. there. No. Yeah. So yeah. See. Ah, fuck. Where do they specify? Damn. Ah, here. And where do you specify this? Pin dot set. What the fuck is all this? Schmidt trigger. Don't know even what that means, but okay, there's something I'm missing. So let me set the const SCL in is GPIO 0. GPIO dot num 0 and SCSD is, no, I think it's the other way around. Yeah, it's 0, this is 1. Okay, with that, excuse me. Don't know what these 3 lines are doing. Okay, let's have a look. Expected function found for. Let me check inline. 14 inline 4. There you go. For loops can be inlined. This causes the loops to be unrolled, which allows the code to do some things which only work at compile time, such as use types as first class values. Don't know what this is. That's it. Why is this an header? Looks correct. Let's P. No, still wrong. But why? Don't know what this syntax is. Let's ask. Sorry, let's ask. Need some water. Let's ask GPT. Whoa, it's new. They made an upgrade. Can you explain what's happening here? Say. And dot. What is that syntax? Hmm. I had no idea. That's cool. So that's how you create anonymous for loops. Sorry, anonymous arrays. Hmm. A little containing 2 pins, yeah. An SDA pin, which are 2 inline pins needed for I2C. Okay, so all this is doing is, what if I don't align it? Expected type found. That's weird. Let me do, I think it might be my LSB date. Zig build. Okay, no, the compiler complains too. Version, no, it's right. Why? Or check the documentation again. the type not be inferred. Don't know what the problem is. Line 4. Damn. Control which allows the code to do something which would only work at compile time. I know. Hang on. Is it because it's like, it's just fucking dangling? Should be within the function. Or a block? Okay, I think that could be it. Yeah, see, this happens inside main. Silly me. Pin config.apply. Take version. Take build. Okay, let's try this. Damn. Ooh, it's quite hot. It's been running for a while. Okay. Whoa. Oh no. It's like there's no error. Of course there isn't. Because code's not in yet. No. Still a motherfucking error. Sorry for all the noise. Oh, yeah. Like that one. Pin config.apply. Just noticed in the example. Never. The UART is the debugger. Okay, now I remember. Is the GPIO pin correct? It's 0 and 1. 0. The clock. Yeah. The white wants the data. Is it connected to the right place? Yeah, it looks like it. First one. GPIO 0. GPIO 1. Yeah. SDA. Yeah. The error still is here because the LED comes on. Does it? Stick. Yeah. Yes. And what are the errors? Check that. Device now present. Oh, it's present. I can see it is right here. It's the power. Guess it shouldn't matter if I flip ground and the other one. But I haven't. Let me just check. 38. Damn, it's dark. 37. Fuck. No. The third one from the top is ground. Yeah. And fuck, of course. It's flipped. Yeah. Yeah. So blue one is ground, yeah. Fuck, I made this mistake last time too. Well, when I was doing the LED. small mistake. Okay. Is that why it was heating up? Nah. No possible. Okay, let's try that once again. Okay, in boot mode. Code. DNS. Oh, where? Hey, the error is gone. Fuck, the display's on. I mean, barely, but it's on. I don't know if you can see it. There. It's like the smallest blue dots. Yeah. Fuck. Yeah, I'm quite happy with that. It looks like a piece of shit, but hang on. See if you let me see. Oops. Can like barely see. That's cool. Fuck. That only took like 4 days to see like I can count the pixels like 10 pixels. That is cool. Wonder that's why it didn't start this whole time. Cause the fucking ground and and the other one were mixed up. Okay. We have progress. I would call it progress, definitely. To be fair, I have no idea what's actually going on. What the fuck is this pink config? I don't think we need this. Why did I even put it there? Yeah, I got it from the examples. Excuse me. blinky. Okay. Leave it at the top. So we'll put this back to 1. Still like to know. Now what I want to know is, did I actually initialize it? What happens if I don't do this? Let's take that out. Yeah. Then build. Fuck. See. Alright. Okay. See what happens. Okay. So it does do something. Because now the display is not on. That's good to know. Let's put that back. Put it back in later. Right. Just gonna be warm. Bit warm. But nothing too bad. It's just me talking to myself. Right. Okay. Fucking display's on. Now. Did he got a few more pixels than I did? Didn't even get that many. And try to turn the entire display on. Oh. This involves... Oh, okay. Write once to the entire buffer. But we have to set up the device to expect this data. Firstly, you choose the desired addressing mode for the display RAM. Did read something about that. Here. Too far? Not far enough. Too far. Okay. Like when I breathe, I can hear it on the mic. Hang on. How about this? Mic test. Okay, this is not bad. Still bad, but not as bad. Fuck is it? Yeah. Decoder. No, this one. So after the initialization, I want to be able to send data. So this one's got to be flipped data byte. And then, so do I send 1 data byte? Or I can send, oh no, there was something with the display RAM. If DC pin is high, D7 to 0 is interpreted as display data written to the graphic display data RAM. Here. What about CO? CO. What about that one? It just stays to 0. Zoom in. Yeah, okay. Where did it go? It was right here. Yeah, this one. DC pin is high. That one. It's interpreted as display data written to the RAM. If it is low, yeah, command. So how do I write data? That's not correct either. Gotta do 32. Yeah. The GDD RAM is a bitmap static RAM holding the bit pattern to be displayed. Static RAM. Size of the RAM is this much. It's divided into 8 pages, page 0 to 7. It's got that many bits divided by 8 per page. No, I don't know. When 1 data byte is written to the GDD RAM, GDDR, it's better. All the rows of the image data of the same page of the current column are filled, i.e. the whole column, 8 bits, pointed by the column address pointer is filled. Yes, I have no idea. It's the theme. It's the theme of this shit show. I have no fucking clue what I'm doing. Nah, it's fine. It's actually much colder now than before the Raspberry Pi. I think it's because all the pins are connected to the right way. Yeah, who would have known? Simple. Okay, let me check what Andrew had to say. Display is set into 4 horizontal pages. No, I thought it was 8. Come on, Andrew, stop confusing me. I'm already confused. Sorry, stop confusing me further. 7. 8 bits tall? The fuck does that mean? 8 bits tall? That sounds funny. 128 bits wide, that makes sense. 28 bits wide. Okay, I get it now. So each page is got 8 by 128. No, that would be too much. No, each page would have 128, and there's 8 of them. 8 times 8 is 64. I guess. Alright, let's see what Andrew has to say. Page-wise with wrapping. The next page, the column-wise, also with wrapping. Things are slightly complicated by the page structure. As you set all 8 height-wise bits of a given page with a single byte. Damn. Seems like the only chat I get is like this. Damn. Smashing tan. Remove the space. Can't even be bothered to put the whole thing. Lazy. Sorry, smashing tan. Rather be alone rather than be spammed. Oh, maybe he's saying I can get viewers for cheap. Oh, there we go. I wonder what's more sad. Like having Overwatch or like paying someone to watch. I think the second one. Okay. See, things are slightly complicated by the page structure. Slightly complicated. Okay. The next thing to set. The next thing is to set the range of pages and columns to draw to. This is useful for more complicated drawings and design, but my range is just pages 0 to 3 and columns 1 to 27. Once I got this all sorted out, yeah, Andrew, I hear you. Banned. However, after a little bit of tweaking and a hefty load of jank, I managed to get things working. You did. How did you do that? Whoa. Oh, okay. Thought the mic stopped working. It's a mosquito here. I gotta write to this page. The green. What was the green one for? Maybe we can ignore the green one for now. So I gotta send 128 bits each page. Just gotta set them all to 1 for now. I just set alternate once. Hang on. So that means it's like initialization, but instead now all I'm doing, do I consider the acknowledgement? The ACK. That was a bit low. Is this better? Yeah, I think it's a bit better. Yeah. So I was thinking, okay, so I said this is 0, this is 1, this is 0, like here, and then I send 1 byte. So I gotta send 16 to fill the page, because 128. Test. I don't know. How does it go to the RAM? And which page? So many questions. Let's have a look. Clock. Power on off sequence. Come on, table. I could reset the display. Oh, I wanted the pixels that show up on the display. It's just like garbage data in the RAM. Come on, table. Come on, table. Setting, come on, table. Hardware configuration. Wonder if you can set colors. Oh, maybe for later. Oh, here. Data read / write. I do. Yeah, I do want. Well, write data. Read is slow. So that's just what? Says our hash. Oh. W hash. The fuck is this bracket? Stop confusing me. Write data. Every time you write, the address gets incremented. To read data from the RAM, select high for both RW pin and the DC pin. Oh, okay, so no, I don't care about this. 6800 series parallel. I want to see the I2C. Okay, let me check Natasha's blog. Okay, display RAM, yes, correct. Seen one of those. Yep, that's where I am right now. Yeah, page addressing mode. Oh, so this is what Andrew was talking about. 3 modes. The wrap stuff. Each lattice represents 1 bit of image data. Okay, let me just read through this. Set lower column start address for page addressing mode. So no, is this supposed to make sense? It's like reading the title, it's like no idea what's happening. The lower column start address for page addressing mode. This command specifies the lower nibble of the 8-bit column start address for the display data RAM and the page addressing mode. The lower nibble. The fuck is the lower nibble? Moving on. The column address will be incremented by each data access. Oh, okay. So I just have to like pass it data and it'll write. But how do I know it's writing from the start and it's like not somewhere in the middle? Ah, because it's been reset? Possible. Okay, yeah, that could be it. Yeah, I guess. I'd like to clear my own chat from the display. Whatever. Set higher column start address for page addressing mode. This command specifies the higher nibble of the 8-bit column start address. The fuck is a nibble? Yeah, it's still not hot. Got distracted. Yeah, right. Column address will be incremented by each data access. Please refer to the section table 9.1 and 10.1.3. This is I hear something. Busy. It's 10.1.3, 10.2, 10.1. And 3. It's not 1.3. Oh, section. Sorry. Oh, you mean the next section. Roger that. There are 3 different memory addressing mode. Page addressing, horizontal mode, and vertical addressing. Maybe this is what Andrew was talking about. This command sets the way of memory addressing into one of the above 3 modes. In there, call means the graphic display data RAM. Here, so this is RAM, 7 pages. Yeah, it's got 128 columns per page. There's 8 of them. Yeah, because it's 8 times 8, 64. 20. That's why. Okay. Now I understand why Andrew said 8 times 4. Where did it go? Yeah. Because I have the 128 by 32, not the 64. Andrew is right. Okay, that makes sense. Yes. Okay, so I only have 4 pages. Good. It's 4 less pages to worry about. Right. Where was I? Yeah. Page addressing mode. This is mean 10x chat. What does this mean? Bit pattern for digital logic hardware or hardware. Yes, it does. What does the 10xb mean? 10xb mean 10xb 10xb. It's funny. Yeah. A0, least significant bit. What? What's the 10xb? Oh. No. No. That didn't sound right at all. 10xb means 10 in binary? Or 10? Nah. No, this is, I mean, to be fair, it's only like very small piece of information. Let's have a look. After the display RAM is read/written, yeah, the column address pointer is increased automatically by 1. Okay, if the column address pointer reaches column end address, the column address pointer is reset to the column start address. Okay. So I gotta know when to update the page. How do I know that? Maybe it says further ahead. Users have to set the new page and column address in order to access the next. Hey, this is after it's written. I haven't got that far yet. I don't care about reading from the RAM. I just want to write to it. Dressing mode. Okay, let's go back to Natesh. See what he has to say. Each byte of the data you send to the display will populate all 8 rows of the page at the current column. Each byte. Yeah. With the LSP populating the uppermost row. Yeah. Okay. Page, horizontal, vertical. Let's go with the page one. Page looks good. Drawing. Yeah. Before drawing to the display, we have to be able to control where the data is being drawn. Fair. This is done by setting the column start and end address, as well as the page start and end address. Column address is 21. How did you... Let's look at the table. Time in, no. Hardware configuration, no. Addressing, setting, command table. Ooh, here. Is this only... Okay. It's more. 2021. Here. Addressing, setting, command table. So let's have a look at 21. Set up column start and end address. Column start address range 0 to 127. Column end address range 0 to 127. This command is only for horizontal or vertical addressing mode. Okay. Okay. So I gotta send the command 21. So X2 to 0. You mean use these 3 bits to set... Maybe. I'm falling asleep. Just woke up. Sorry. Command column address 21. Command set page address 22. What does 22 do? Set a page start and end address. Okay, that's the command. Yeah. What is start? 0. Set start and end column address. set column address, start and end, both U8s. Guessing 0, then 128. Set page address 0 to 7. Oh yeah, the column address will be set as you're writing, or when you just before you write to the page. Guessing. Okay. Send command. Set page address. Start and 07, which is 7. Okay. And 07. I think for me it will be 0 to 3. Is that correct? Maybe. Create a page buffer. Yeah. Set it to FF. Quite don't know what that is. Whatever, FF. So the column bounds to the full width of the display. OLED dot set column address. So here OLED 0 127, right? Set page 0 7 7 and 7 is 7. 0 and 7 is 0. Right. Okay. Maybe I'll look into it when I do write it, but I think there's more to it. Or maybe not. Send buffer. Send buffer. I did read about that. Here. Okay. Writes control data and you send the buffer of I. Okay. Size of page buffer. Okay. All right, I'm losing concentration at this point. Damn. Okay. I mean, not bad. I would say not bad at all. Got the display turned on. Let me commit. Display is on. Yeah, I'll take that for today. And I guess probably tomorrow the goal will be to write stuff on the display. Right. Okay. I think that's all for today. Have a good one. Bye.